Hello AP Chem students and welcome to topic 7.10, reaction quotient and Le Chatelier's principle. This title is a little bit off. I fondly refer to Le Chatelier's principle as Le Chat. I like to joke and say that we're going to Le Chat all over the place because that is what we do when we adjust something about a system that's at equilibrium. So in learning objective 7.10.a, we're going to explain the relationships between Q, K, and the direction in which a reversible reaction will proceed to reach equilibrium. So if you remember, we already talked quite a lot about Q versus K in my video for 7.9. I probably went a little bit more in depth into that than I needed to in 7.9, but that's okay because it's all content that you're going to need to know. So we just examined how we can apply Le Chatelier's principle qualitatively. So while we did talk about how Q and K are impacted, we did it in terms of like the denominator will increase or the numerator will increase. So we were not actually comparing numerical values directly, which you can actually do. So you can quantitatively do that by calculating the value of Q after the stress has been applied and comparing this new value of Q to the value of K. And so that would look like this. And this is very similar to graphics that we have looked at before. So this is not a new idea, right? The only difference here is that so far we've been talking about Q as an initial set of conditions, and now we're talking about Q as a set of conditions after equilibrium has been established, but then you change something, you stress it. And so then you have to see, are we still at equilibrium? So again, back to this idea that Q can stand for question. Are we at equilibrium or are we not? So that's why we don't specifically say that a Q is calculated for initial conditions only. A Q can be calculated anytime that you don't know if you're at equilibrium. Okay, so this comparison, this Q versus K comparison, allows us to see in which direction the reaction species redistribute to bring Q and K back into agreement. All right, so just a quick summary. This is a slide from my video on topic, what was that? 7.3 maybe? No, it was not. It was calculating equilibrium concentration. So video 7.7. We talked about what happens with the Q versus K, and this is exactly the same conversation. The only difference in this case is that in that case, we didn't know in which direction the reaction was going to proceed to begin with. Now the reaction has been going for a while. It reached equilibrium. We're going to stress it, and now we need to figure out which way it's going to shift. You can still use the word proceeds to reestablish equilibrium, but nothing else changes. So if Q is less than K, then the system will still shift right, exactly as it did here. It's going to shift towards the products. If your Q is greater than K, then your system will shift left towards your reactants. If your Q is equal to K, then the system will not shift because the stress did not impact the equilibrium. Your Q is equal to K. It will continue as it was before the stress was applied. Remember that if the stress is a change in temperature, then the value of K changes, and it still causes a shift in the system, but we would not discuss that in terms of Q versus K because that actually changes the K value itself. And I think I said this before, but we'll examine that a little bit more as we go forward. That is it because we did so much with the Q versus K in topic 7.9. Now, I have not showed you an example or anything of that nature, but that's because you really already know how to do this because we went pretty in depth into how to calculate Q. We've compared it to K. We've talked about if it's greater than or less than. All of this is the same. So Le Chatelier's principle is just the idea that we can stress a system, think about how that impacts the concentrations or the partial pressures of the components, and then how the system will readjust. So the idea behind equilibrium, and this is really important to keep in mind, is that equilibrium is a state at which the reaction normally settles out. It's just kind of the reaction's happy place, if you want to think about it like that. So the reaction will always reach that ratio, that proportion of reactants to products. And if you stress it, it's just going to go back to that same ratio. It might take it some time, but it will reestablish that equilibrium. Okay, so what should you be able to do with this? Two things. Number one, evaluate Q versus K to determine the direction in which a reaction will proceed to reestablish equilibrium. Generally in this class, you will not have to calculate a new Q. You will need to just be able to think about what we did in the last video with the numerators increasing or decreasing or the denominators increasing or decreasing, what that does to Q versus K. So you can do it what I like to call kind of semi-qualitatively, semi-quantitatively. And then finally, determine if a stress will change the value of Q or change the value of K. That is pretty important. They like to ask you that question. And then sometimes also to know what does not impact Q or K. And that would be, again, catalyst does not change Q or K, or adding an inert gas would not change Q or K. That's it. That is our wraps up our discussion of Le Chatelier's principle. The next topic we'll get into 7.11 and 7.12. We'll deal with solubility, equilibria. So I will see you soon for those topics.